Chapter 23, Respiratory Anatomy, Screencast 1. This series of screencasts will be focusing on the anatomy of the respiratory system. But before we go there, we want to talk about what are the primary functions that are associated with the respiratory system. The one that is most obvious is going to be the role of gas exchange of our respiratory gases, and those are oxygen and carbon dioxide. Now, when we talk about gas exchange, it's going to occur in two different places. We're going to look at the exchange between the atmosphere and the body cells, and this, once again, happens in multiple places, which will be addressed in much greater detail in the next series of screencasts focusing on respiratory physiology. Now, the need for oxygen basically is for the aerobic production of ATP. And remember that one of the byproducts of the production of ATP is carbon dioxide that we need to get rid of. So the respiratory system is that system that is responsible for providing the means in which these processes can actually take place. Now, when we look at the primary structures and organs that make up the respiratory system, they're going to be the passageways in the head, neck, trunk, and the lungs. Now, if we look at a passageway, all it's really doing is moving air between the atmosphere and the alveoli. And we need to remember here, this really isn't going to be exchanged. Now, the exchange of oxygen and carbon dioxide, we're going to actually see it happen within the alveoli, and oxygen will diffuse from the alveoli into the blood, whereas carbon dioxide is going to be moving in the opposite direction from blood into the alveoli. Another function that is associated with the respiratory system is the detection of odors. We have many olfactory receptors that are located in the superior nasal cavity. And another really important function that's tied into the respiratory system is the production of sound. Air will move across the vocal folds of the larynx, and those cords will vibrate, resulting in the production of some type of sound. Now here, we're looking at the very general anatomy of the respiratory system, but I want to point something out that I think is especially important. We're looking at two different ways of organizing the structures of the respiratory system. One is a structural organization, and I don't find this to be very helpful because basically it's made up of the upper respiratory tract and lower respiratory tract. That really does not give you any idea of the function, what is happening. But let's take a look at the functional organization. And here we have what we refer to as the conducting zone and the respiratory zone. This is actually referring to what processes are actually happening in these two different parts. In the conducting zone, we're looking at basically airway, nothing beyond the movement of air. There is no gas exchange, where gas exchange will be limited to the respiratory zone. And the structures that actually make up the respiratory zone are going to be the respiratory bronchiole, the alveolar duct, and the alveoli. Now, we are going to be introducing a really important concept here. And if we talk about the mucosa, that is the mucous membrane, and that is the innermost lining of the respiratory system of that tube. And I've addressed this before. I put a very significant emphasis on the mucosa because that is the layer of the tube that is going to be in contact with whatever happens to be in the tube itself. Now, let's take a deeper look at the respiratory epithelium, and there's something very characteristic happening here. So here, notice what happens as we get deeper into the respiratory tract. The epithelium is going to be much, much thinner, and we can see that progression here. So we're going to start off with the pseudostratified ciliated columnar epithelium, and this will be lining the nasal cavity, the paranasal sinuses, the nasopharynx, the trachea, the inferior portion of the larynx, the main bronchi, and lobar bronchi. Then we're going to have a simple ciliated columnar epithelium, and this will find lining the segmental bronchi, or secondary, the tertiary bronchi, and then our larger bronchioles. Then we're down to a simple ciliated cuboidal epithelium, and this will be lining the terminal and respiratory bronchioles. So notice we're starting to lose a loss of cilia, so that's part of the progression. And then eventually we're going to get to the simple squamous epithelium that is going to form both the alveolar ducts and the alveoli themselves. So notice what's happening here. upper in the airway, we have air first coming in. We're going to have the cilia that will be sweeping the area for particulates, and so on. As we get deeper and deeper into the respiratory tree where gas exchange is actually going to occur, we get to the simple cuboidal or the simple squamous epithelial tissue. And keep in mind that is going to be a single cell layer and really critical in the process of gas exchange. Now, there are some exceptions, and there are areas in the respiratory tract that we are going to find non-keratinized stratified squamous epithelial tissue. This will be found in those areas that are subject to mechanical stress and so on. So if we're going to find some examples, they're going to be the oropharynx, the laryngopharynx, the vocal cords, and the superior portion of the larynx. So that's where we're going to find the stratified tissue. Now, there are going to be quite a few secretions that are going to be produced by the respiratory mucosa, and primarily we're going to be looking at goblet cells, which are part of the epithelial lining, and we're going to see also these mucus and serous glands of the lamina propria. Now, when we talk about this secretion, it's a mucin protein, and the role is to actually increase the viscosity, and as a thicker fluid, it's going to trap dust, dirt, pollen, etc. This is probably a really kind of gross example, but I kind of think of going to an old country store up in the Adirondacks, and you see this fly paper that's hanging there, and it looks like it's not been changed for decades. And that's what's happening here. We basically have this mucus, and it is going to trap things that as we inhale them, and eventually we're going to get rid of them in some manner. When we look at the amount of mucin that's actually produced, we're looking at 1 to 7 tablespoons daily. Now, within, we're going to find a different, some antimicrobial agents. We'll have lysosome, that is an antibacterial enzyme. We'll have defensins, those are antibacterial proteins. And we're actually going to find immunoglobulins that are antibodies. Now, we've all kind of experienced an upper airway infection, and when we start to see that thick, viscous mucus, it's going to be coughed up and it's trapped, and that's what we refer to quite often as sputum. Now, here we're actually looking at some of the skeletal components of the that are part of the respiratory system, and we're putting an emphasis primarily on the nasal cavity region. So we're not going to spend a lot of time on the olfactory areas, but I want to put an emphasis on the concha. And we're going to have a superior, middle, and inferior concha, and they're going to play a really, really important role. Here we can actually see a number of the sinuses that are also going to be a part of the anatomy of the upper airway. Now, we have these ducts, and these are nasolacrimal ducts, and what they're going to do is basically drain secretions from the eye surfaces into the nasal cavity. And once we're in the nasal cavity, we're going to see a very important function that's played, and it's called the conditioning of air. So what's happening as air is moving through, the nasal cavity, and most of us actually breathe through our nose. So this air will actually be warmed, cleansed, and humidified. Now, the air is going to be warmed by extensive blood vessels. Anyone that's ever had a bloody nose knows how much blood can come from a bloody nose, and it makes sense here. So we have very superficial blood vessels. They're close to the surface, and they're going to be warming the air as we inhale. If we look at the concha, these are these protrusions, and what they're going to do is basically create a turbulent flow, and that turbulent flow is just going to move the air and spend more time and really enhance the overall process of conditioning the air. So we'll see mucus that's going to be trapped, microbes and foreign material. The cilia will actually be sweeping mucus towards the pharynx to be swallowed. We actually have something that we refer to as the mucus escalator. So basically the movement of mucus and particulates trapped in the mucus so that we can expel them from our body. It also is a moist area, So that environment is going to result in humidifying the air that we breathe. So a really important function is being carried out here by the nasal cavity, in particular the role of the concha. Now, the last thing we kind of want to talk about are sinus infections and sinus headaches. So what's not uncommon, it could be a allergy response or a respiratory infection. And what happens basically, you get an inflammation of the ducts that drain from the paranasal sinuses. Now, this drainage of the mucus is going to decrease and it actually accumulates in those sinuses. So now we're actually going to see the growth of germs and bacteria in this accumulated mucus, and that is where the sinus infection is originally originating from. And so when we look at these sinuses that are inflamed and blocked, okay, there's going to be some pressures, and these pressure changes can actually result in sinus headaches due to the accumulation of the fluid and so on that we happen to be occurring within the sinuses themselves.